Hello, everybody, and welcome to this week's would-be in-class assignment. Normally, again, we would be doing this in class, and since we've already gone over the first few chapters, this is not specific to any chapter in the book. Maybe it would be closest related to chapter 3, where we talked about the types of designs. And because we are doing sort of a half lecture, half lab type of thing, what we are doing in the class at this point is to go over how to evaluate research designs. So this sort of builds off of the proverbs that we did a couple weeks ago, where we looked at how to make something a correlation and how we can look at criterion variables and predictor variables, as well as how to turn that into a research design, like a true experimental design, what we would call a causal claim, according to the book. So for this assignment, I would like you to do points A through F. Now we have 8 questions on here, I think, and you only have to choose one question. So one of these questions I would like you to do, and you just have to go over the type of research that's described. So for each item below, do all of the following. The reason it says each item is because I usually in class group people up and put you into, when you're grouped up in groups of 4 or 5, I basically assign one of these to you guys. So each group would do one. So as individuals in this case, I just want you to do one. I don't care which one you choose, but just choose one of them. You don't have to answer all of them unless you're really feeling frisky. I don't know why I said that. So I want you to do A through F. A says identify the type of research described, whether it's correlational, which of course is an association claim. Is it experimental, a causal claim, or is it neither? Or maybe we don't have enough information. It should be one of them. B, identify if it is correlational. Remember that the key words are correlation is 2 measured variables. So they would be the predictor variable and the criterion variable. And so B and C would be the same if it's a correlation. This says identify the independent or predictor variables. C says list the levels of the independent or predictor variables. Now, as you should know by now, a correlation doesn't have levels. We measure one thing, we measure another. Measured variables don't have levels. Independent variables have levels. So if I were to use Crazy Cat Lady as an example, and you wanted to see if there was a correlation between the number of cats a person owns and their sanity, your predictor variable would be the number of cats, and there's, again, C wouldn't matter because there's no levels. And D says list the dependent variable or the criterion variable. So if the predictor variable is number of cats a person owns, criterion variable in this case would be the number or the score on a sanity survey or something like that. Crazy scale. I don't know how you would want to phrase it. And the scale on which it would lie, you're either looking at a ratio or an interval scale of measurement. If it's the number of cats, which could be 0, 0 means none. You can get a 0 on the crazy scale. Means for the criterion variable at least would be, both of those would be ratio. Now, if one of them is a Likert scale on a scale of 1 to 7, how much you agree or disagree or like or dislike something, obviously that would be interval. So A is the type of design. If it is correlational, you skip C and just do B and then D, or you would say for C, no levels. And then D would be the criterion variable. If it is an experiment, IV has at least 2 levels. As we talked about, the independent variable, study, not studying, right? N versus I, those would be the levels. So if we were to look at the Stroop task, the type of research described would be experimental. The independent variable would be word list. The levels of the independent variable in C, this is where C would come in, those levels would be neutral and interference, or it would be amount of studying for B, and based on my own example from before, and the levels would be 0 hours versus 6 hours of studying. D is the dependent variable. That's our measured variable. So that would be for the studying example would be the exam score, which of course would be ratio, just as the reaction time would be for the Stroop task. And again, you don't have to go into like the specific operational definition. Just tell me the dependent variable and the scale. So that would be the reaction time, or the amount of time it takes to read the list or finish the list, and that would of course be a ratio scale of measurement, as hopefully you wrote in your paper. Evaluate any conclusions that are drawn. What are we looking at? What conclusions can we make from what's written? And then F is my favorite part. I would like you to point out any problems you find with the design of the study or the conclusions that were drawn, and maybe suggest some ways to correct these problems. So as always, I have an example to give, and then I will give you guys the other questions. And again, you just have to answer A through F. And if it is correlational that you decide, then you would not have to answer C, because there's no levels for 2 measured variables. Levels are only for independent variables, or IVs. So I'm going to go through this example, and then I will let you guys choose which of the 8 questions you want to answer, A through F. And yes, you only have to give me the answers A through F when you're turning it in. But here we go. A psychologist wanted to test her hypothesis that the language used in eyewitness testimony can alter memory. And you'll see why this is important coming up. Thus, they aimed to show that leading questions could distort eyewitness testimony accounts and have a confabulating effect. Confabulating means that you're saying something that's false that you believe to be true, as the account would become distorted by cues provided in the question. This has to do with memory. To test this, the psychologist asked people to estimate the speed of motor vehicles using different forms of questions. And here's what they did. Subjects watched 7 films of traffic accidents, ranging in duration from 5 seconds to 30 seconds, and they were presented in a random order to each group. So basically, subjects watched all 7 films. After watching the film, participants were asked to describe what had happened as if they were eyewitnesses. Then they were asked specific questions, including the question about how fast were the cars going when they smashed, or collided, or bumped, or hit, or contacted each other. The estimated speed was affected by the verb used. The verb implied information about the speed, which systematically affected the participant's memory of the accident. Thus, the researcher concluded, here's your conclusion, that eyewitness testimony might be biased by the way questions are asked after a crime is committed. So, for this one, we ask, is it correlational, experimental, or neither? Well, you can see that they were in groups that were watching a film either from 5 to 30 seconds, and given these questions afterwards. So this is a research experimental design. So it was experimental. Here's the only thing we don't know. They didn't say how many people per group. And so we would say that it's experimental, except the only thing we don't know about this is if the groups were randomly assigned or if there was a control group that did nothing. What was the independent variable? The independent variable would be defined as the wording of the questions. How fast were the cars going when they smashed, collided, bumped, hit, or contacted each other. So here in B, you can see the IV was, we would say, the word or the verb in the question. The verb used could be a good way of saying it. So what were the levels? The levels were the verbs themselves, right? Smashed, collided, bumped, hit, contacted. So I guess that would be 5 groups. And all the groups watched, I guess, all the films. So the IV levels were the verbs that were used. What was the DV? The DV was, what were they measuring? They were measuring how fast the people, eyewitnesses, thought that the cars were going based on the verbs. So the DV was, again, speed reported by the participants. What is it that we're measuring? Remember, the IV is what groups they're put into or how they're manipulated. The dependent variable, of course, is the measured variable, aka what number are we measuring from this experiment. So the DV is the speed reported by the participants. E says what conclusions were drawn. What we saw for this causal conclusion is they said that it might be biased by the way questions are asked. Remember, when we talked about it in the first couple chapters, we never want to say prove. So if you see that in a conclusion, this proves, definitively proves, then you know that's a bad conclusion, because in this type of research, we never use the word proof. If we go back up top, the verb estimated speed was affected by the verb used. That it might, right here, it might be biased by the way questions are asked. This seems like a really good conclusion. So here, the causal conclusion was good, since they said it might be biased by the way questions were asked, and that's basically what they found in the study. So they did get that right. And then F, here is what are the problems here? So one of the things we already pointed out in the beginning is we don't know if the groups were randomly assigned. We don't know what the control was, so you could say that for F. What other problems might we have seen in here? It didn't say whether there was a control. They didn't describe a control. We also don't know how the subjects were assigned. Random assignment is a very specific thing to avoid against things that we'll learn in the next module. Independent variables. Internal validity problems. So that's part of it. What else? No idea about subject assignment. We also don't know what other elements in the room could have factored in, so we don't have all the information. We do know that all the groups apparently watched all 7 videos. The only difference between the groups was what verb they used in that question. So that stuff checks out. And so your job is to think like a researcher and to try and figure out if there are any flaws. So let me read through the questions for you, and then you basically can just copy and paste the actual question and then the A, B, C, D, E, F, and then answer that on a separate sheet. So number 1 says, a forensic psychologist found a significant positive relationship, that might be a hint here, between ice cream sales and the number of murders occurring in New York City. He concluded from this finding that the sugar in the ice cream had some sort of excitatory effect on individuals, maybe hypered them up, causing them to be more likely to commit murder, thus leading to an increase in the number of murders in the city. Now, this is not Tide Pods. This is ice cream. So let me know if you choose this one, what type of design, what are the predictor and criterion or IV and DV and levels, what's the conclusion here, is it a good conclusion, and what kind of flaws do we find in this study? Number 2, a market researcher was asked to evaluate 3 models of skis, model A, B, and C, to determine which was the fastest and should be marketed. She hired 30 expert skiers to test the skis. Each skier was fit with a pair of skis of each model type. To control for the possible effects of extraneous variables, meaning that A and only A causes B and not something else, extraneous variables, the boots and the other clothing worn by the skiers were held constant. So they all wore the same boots, same type of clothing. The only thing that was different, hopefully, was the actual types of skis. Similarly, to control for order effects, remember we talked about order effects with the Stroop task, all skiers use the 3 models in the same sequence, A, B, C. So the first run was with A, the second run was with B, and the last run was with C. Finally, to avoid fatigue, she had all skiers make their first run at 9 a.m., next one at 11 a.m., and the last one at 1 p.m. After analyzing the data, there's a typo here, sorry. She found that the run times were significantly faster for, I'm just going to erase it here so you can see what I did wrong. That the run times were significantly faster for A, 4 minutes and 47 seconds on average, than for B, 5 minutes and 15 seconds, and also for C, 5 minutes and 33 seconds. She advised the manufacturer then to market Model A. So, what type of design is this? What are the variables involved? What is the conclusion? Is it a good conclusion? And are there flaws here that you can point out? Number 3, Mr. T. He pities the fool. He's a personal trainer. The T stands for trainer, apparently. Is fairly certain that exercise prevents one from coming down with colds. To test his idea, he and his assistants visit a number of parks located throughout a large metropolitan city, perhaps Los Angeles, and interview people who are there. Doing this for several consecutive weekends, they are able to interview several hundred individuals, and from each, they obtain an estimate of A, how much he or she has exercised each week over the past 6 months, and B, how many times he or she has come down with a cold over this time period. Mr. T is pleased to learn that almost everyone interviewed exercised at least 4 hours a week, but he's disappointed to find that as individuals report exercising more hours a week, they do not report fewer numbers of colds. He thus reluctantly concludes that there is no relationship between exercising and the likelihood of coming down with a cold. So here's A through F, and answer that if that's the one you'd like to. Number 4, a clinical psychologist advertised in the newspaper for individuals who want to quit smoking, offering $100 to individuals who would try a smoking cessation program. Cessation meaning to quit. After volunteering for the study, individuals were randomly assigned to one of 2 programs, either the researchers' new Quick Stop program, which is the one being studied, or a standard graduated filter, which means that the filter gets longer and longer, so there's less and less of the tobacco and stuff. Cessation program. So you're kind of, it's a quick one, like a kind of a cold turkey program versus a like weaning off of it, right? Program. Cutting down partially. 20 participants began in each program, and 12 and 18 finished the QS and GF programs respectively. So they both started with 20 and 20. 12 finished in the Quick Stop, and 18 finished in the graduated filter. 4 months later, she surveyed participants who had finished the programs and found out that 75% of the Quick Stop group were still non-smokers, whereas only 50% of the graduated filter group were still non-smokers. Statistical analyses looking at those indicated that the difference between the groups was significant. Thus, the psychologist concluded that the Quick Stop program was more effective. What type of design is this? What are the variables? What is the conclusion? Is it a good conclusion? And are there flaws, and what are they? Number 5, if you so choose. A psychologist, Dr. Schachter, investigated the relationship between, this one's probably my favorite of them all. That doesn't mean you have to do this one, but it's probably my favorite that I wrote. Investigated the relationship between caffeine intake and memory ability. On the day of his experiment, the first 8 participants to arrive at the testing room were assigned to the high caffeine condition, in which each participant consumed 72 ounces of Monster Energy drink. The next 8 participants were assigned to the low caffeine condition, in which each participant consumed 36 ounces of Monster Energy drink. The final participants to arrive were assigned to the no caffeine condition and were given nothing to drink. After the participants in the high and low caffeine conditions had finished their drinks, participants in all 3 groups studied a list of words, 50 words, presented on a screen for 3 minutes. Then, following a 1-minute rest period, all of them were asked to recall as many of the words as they could from that presentation. Dr. Schachter found that the participants in the high caffeine condition recalled significantly more words than those in the low caffeine condition, who in turn recalled significantly more words than those in the no caffeine condition. Then, based on this, Dr. Schachter thus concluded that consuming caffeine seems to improve one's memory. Number 6, a market researcher for a real estate agency investigated what types of people were likely to buy what types of houses. He randomly selected a large number of homeowners, and among other variables, he recorded how many pets they owned and how many rooms were in their homes. Interestingly, he found that as the number of pets people owned increased, the number of rooms in their homes also significantly increased. He thus advised his real estate agency that they should pitch their advertising for their larger homes to pet owners and place ads in media that tended to be seen or heard by pet owners. Please answer the following for those. Number 7, a political psychologist asked randomly selected third and fourth year undergraduates at a large university in the United States to indicate their willingness to support a qualified female candidate for their presidency on a scale of 1, very unlikely, to 5, very likely, as in to vote for a female candidate. He then examined the transcripts of the students and recorded how many science and math courses they had taken since coming to the university. He discovered that the more science and math courses a student had taken, the less likely they were to be willing to support a qualified female candidate for the presidency. He then concluded that studying math and science tended to make people less progressive in their political attitudes. Again, we're looking for A through F. And finally, if you so wish, number 8 says an investigator studied the relationship between amphetamine intake and aggressive behavior in rats. 20 male rats were obtained as pups and reared in individual cages. When the rats were 90 days old, she began giving them daily moderate doses of amphetamines. After 2 weeks, she randomly assigned the rats into pairs. Then she put one pair of rats at a time into a small cage and observed their behavior for 10 minutes to see if any aggression occurred. The investigator concluded that taking amphetamines causes aggressive behavior in rats. So if you choose this one, again, what type of design is it? What are the variables? And if it's a causal claim or an experiment, what are the levels of the IV? And what's the DV or criterion variable? What is the conclusion and is it right? And what are the flaws, if any, and how maybe would you fix them? So that is how you do this assignment. Thanks for listening to this tutorial, and best of luck with this assignment. I hope you have fun with it. And as always, I will talk